So this is again an applet from the astronomy education at the University of Nebraska-Lincoln. And so what we see here is certain date. I chose January 1st to begin with. The sun is relatively low in the sky. This is in the, well, kind of mid-afternoon, right? It's virtually 2:30, so close to 3 o'clock. The sun is pretty low because it's January. And then when I start the animation, and this goes day to day, okay, so the sun is not going to go left to right, east to west, but it's day to day at the same time. And notice, of course, as the dates progress throughout January, the sun would appear higher in the sky. Of course, it would move throughout the day, left to right, but here it goes, of course, higher into the sky. This is March now, and this is, of course, due to the axis, and it makes that line up there. But if you look really carefully, it's not just a straight line that makes up and then eventually down. This is in May now. It's going to stop very soon here in June, and it's going to go back down. Again, this is day-to-day animation. It's not just a straight line, but it actually has a couple of loops or lobes to it, which are also caused by the tilt of the axis and by Kepler's second law, as in January we're a little bit closer to the sun, so we're orbiting a little bit faster, and in July we're a little bit further away from the sun, so we're orbiting a little bit slower. So it's those two things, the tilt of the axis and that one. I'm going to show that Analemma, actually, that's what it's called. Respectively, it's also being used as the equation of time. This is before we had radios, so a long time ago, 19th century is what I'm talking about, where people had to adjust their clocks because the sun's motion had those kinds of lobes in a day-to-day motion, and in order to have accurate clocks, you couldn't totally rely on it because of this Analemma. In the meantime, you also see that stick figure, you know, the shadow is getting shorter and longer, right? Which tells you about that, yeah, the sun is getting higher in the sky, and if you were further south or north, then your shadow lengths would also be different, which would tell you then about the curvature of the Earth. But that's beyond what I wanted to show here, which is basically that beautiful Analemma that you can see in some photos.